Before you write a single line of code, ask yourself, what am I building and what will it become? Without the right software architecture, even the best code becomes hard to manage. You might have clean code, a great team, and millions of users. But if your foundation is shaky, things will break, slowly, then all at once. In this video, I'll break down how architecture can make or break your app, from simple systems to scalable SaaS platforms. So, what is software architecture really? It's not just diagrams or design patterns. It's the high-level structure of your system, how components interact, how data flows, and how decisions today shape the code you'll live with tomorrow. Think of it like this. If coding is like laying bricks, architecture is your blueprint. You can build fast without one, but the taller your product grows, the shakier it becomes. Before you know it, features take weeks to ship, bugs reappear in new places, and onboarding new developers feels like a rescue mission. The worst part? You often don't feel the pain until it's too late. That's why understanding architecture early, even at MVP stage, is one of the smartest things you can do as a developer or technical founder. We will go through the essential concepts, common architectural patterns, and how to think clearly about what your product really needs. Not just today, but 6 months from now. Let's start by defining what software architecture actually includes. Most systems, no matter how simple or complex, share a few key layers. At the top, you have the front end. This is what users see and interact with. Beneath that, the back end, handling business logic, user data, and communication. And then the database, where everything is stored. But that's just the surface. Real-world systems also include APIs for exposing or consuming data, authentication layers, queues or message brokers for async operations, and sometimes external services like payments, emails, or AI. These components exist for a reason. They help us split complex responsibilities into manageable, isolated parts. And that leads us to one of the most important principles in software architecture: separation of concerns. That means each part of your system should have one job and do it well. Your front end shouldn't care how the data is stored. Your back end shouldn't care how it's rendered. And your database, well, it should store data. It's also helpful to distinguish two levels of architecture. Code architecture, like how your functions, classes, or modules are structured. And system architecture, which is the bigger picture, how your services talk to each other, how they scale, and how data moves. You don't need a PhD to get this stuff right. You just need to understand the layers, draw clear boundaries, and keep things loosely coupled. In the next chapter, we'll explore the most common architecture patterns, like monoliths, microservices, and modular systems, and when to use each. Now that we understand the core components of a system, let's talk about how they're organized. This is where software architecture patterns come into play. They define how your system is structured, how it grows, and how manageable it stays over time. The first and simplest pattern is the monolith. A monolith is a single unified codebase, one app, one deployment. Everything, front-end logic, back-end APIs, data access, is tightly connected. Monoliths are fast to build, easy to deploy, and perfect for MVPs. But as your product grows, the code can get tangled. One change in one corner of the app might break something you didn't expect on the other side. They're great until they're not. A better version of this is the modular monolith. Same code base, same deployment, but your system is broken into clear modules or domains. User management, billing, analytics, etc. Each module has its own responsibilities and communicates through well-defined interfaces. This gives you many of the benefits of microservices without the overhead. It's an excellent middle ground, especially for startups or small teams. Next up, microservices. In this model, each part of your system is its own independent service. Billing is one service. Authentication is another. They have their own code bases, databases, and even separate deployments. Microservices are built for scale. Teams can ship faster, independently, but they also introduce complexity. More infrastructure to manage, tougher debugging, distributed failures. If you're not already dealing with scale, this pattern might be too much too early. There's also serverless. Instead of managing a server or service, you write small functions that run on demand. Great for event-driven tasks like sending emails or processing images, but harder to use for apps with lots of shared state or complex workflows. So which pattern should you choose? That depends on your team, stage, and product complexity. Architecture isn't about what's trendy, it's about what's appropriate. In the next section, we'll explore how to pick the right approach for where you are right now, and how to evolve it as you grow. So, which architecture should you choose? The answer isn't about what's cool. It's about what fits your product stage, your team, and your goals. If you're building your MVP or just starting out, keep it simple. A monolith, maybe even a modular monolith, is usually your best friend. It's fast to build, easy to deploy, and lets you focus on validating your idea. You don't need Kubernetes. You don't need 6 separate services. You need to ship, learn, and iterate quickly. Over-engineering here is a real risk. It slows you down before you even have users. As your product starts growing and your team gets bigger, complexity creeps in. Now is the time to think about modularity. Break your monolith into clear domains: auth, billing, analytics, user profiles, whatever makes sense for your business. This makes onboarding easier, debugging cleaner, and scaling more manageable. You're not doing microservices yet, you're just drawing stronger boundaries within your app. Once you're dealing with high traffic, multiple teams, and independent deployments, that's when microservices might start to make sense. You've likely hit limits: long CI pipelines, painful merges, or risky deployments. Microservices let teams move fast independently, but they come with real trade-offs. More infrastructure, more monitoring, more DevOps maturity. The key is this: don't start with the most complex setup just because some big tech company uses it. They didn't start there either. Start with what makes sense today and evolve as you grow. Good architecture isn't static. It adapts with your product. Thanks for watching, and remember, software is temporary, but architecture is what holds it together.